So we're going to look at finding the curvature for a function of x now. And we first want to understand that we can parameterize any function if we simply take x as x and y as the function itself. It's sort of a cheap way of coming up with a quick parameterization for your function, but it actually serves us pretty well. And this is going to be a bit of a derivation of our formula here before we do an example. So we can take a vector valued function now where x is x and y is equal to the function f of x, whatever it's given. And this might be something like f of x equals square root of x or sine x, any of our regular understandings for what a function would be. And from there we go ahead and apply our curvature formula to this particular vector. And we'll go ahead and find the magnitude of r prime. We're going to cross that with r double prime. And then we'll have the magnitude of r prime cubed, and that'll be our curvature. In this case, it will be a function of x, though. So let's find r prime. So r prime of x here is going to be equal to 1, and the derivative of f is f prime of x. And r double prime is 0, and f double prime of x. So now we need to take the cross product of that, but of course that's a little challenging because these are two-dimensional vectors. So we can adjust for that by allowing the z-coordinate to be 0. So we get 1 f prime of x and 0 and 0 f double prime of x and 0. And now we've got a couple of vectors that we can form the cross product of. So let's take a look at that. So r prime cross r double prime is going to look like I, j, k. And our first vector is 1 f prime of x and 0. And then 0 f double prime and 0. So let's go ahead and find that cross product. And when you do that, this works out as simply f double prime of x for the k component. The I and j's end up being 0. So now you would take the magnitude of that. Of course, it's just a single component anyway, so its magnitude is equal to the absolute value of that function. So our magnitude then of r prime cross r double prime is just equal to the absolute value of f double prime of x. Okay, so now we need the magnitude of r prime. We already know what r prime is, so we would take that and compute it. Here's our r prime. So we're going to take the square root of 1 plus f prime of x squared, square rooted. So that's our r prime magnitude. And now to form the curvature, k of x is going to be equal to the cross product, which is the absolute value of f double prime of x, divided by the square root of 1 plus f prime of x squared. And of course, we're going to cube all of that as part of our formula. So now, if we want to just simplify it down a tiny bit, we end up with something that looks like this, our normal formula that we would use for this. So we take the absolute value of f double prime of x, and then we divide it by 1 plus f prime of x squared, all to the 3 halves. And that's our typical way of writing out this formula for curvature of a function of x. So now we don't really have to go through this whole process every time. We could, but we don't have to. The important thing maybe for us is to recognize that we didn't really do anything different through here. We just applied our normal understanding of curvature and created this pseudo parametric function here to allow us to take its cross product and find these other quantities. And then ultimately we ended up with this formula here at the end. So if we simply want to just apply or remember this formula, that's one thing. But again, we didn't do anything specifically different from computing a curvature for any other type of function. So now if we want to work through an example, we can do that. And here what we'll do is we'll take y equal to the natural log of x, and we'll go ahead and find that curvature. So we're going to need f prime, or y prime, either way. Derivative of ln of x is 1 over x, and we also need f double prime, which is negative 1 over x squared. And now it's just a matter of plugging them into our formula above. So k of x is equal to the absolute value of f double prime of x. That's going to be the absolute value of negative 1 over x squared divided by, and now we get this quantity in the bottom, 1 plus f prime of x squared, which will be 1 over x squared. And we're going to raise all of that to the 3 halves. Now in the numerator here, you're taking the absolute value of something that is negative, so that negative will go away, and it's really 1 over x squared here for the rest of it, and that will just always be positive. So we can replace that numerator with a simpler expression here of 1 over x squared, and then the denominator will stay the same, 1 plus 1 over x squared to the 3 halves. And I suppose if we wanted to clean this up just a little bit more, we could bring the x squared here into the denominator. So we would maybe finish this off by writing it as 1 over x squared times 1 plus 1 over x squared to the 3 halves. And I think I'm pretty satisfied with that.